Hi students, today we are going to discuss about special electrical machine, in that a repulsion motor. As the name represents repulsion motor, we have this motor operates under the repulsion principle. But what repulsion, whether it is electrical or magnetic, that we are going to discuss in this topic. So today we are going to discuss about repulsion motor, and this is the practical motor which was used past 10 to 20 years before, 20 or nearly 40 years before. And this is the circuit diagram of the repulsion motor. To make you clear that, you just see the stator and the rotor. The rotor is not connected with the stator, and the brushes are shorted. Depending upon this is the main part. The brushes in repulsion motor, we can make run, start, stop, and rotate clockwise directions, changing the clockwise direction, changing the direction of the rotor movement. Everything can be done through this. So what is meant by repulsion motor? A repulsion motor is a type of electric motor which runs on alternating current. It was formerly used as a traction motor for electric trains in Class C and SR class, but has been superseded by other type of motor. So it is not being used currently for traction or in trains. SR class means Southern Railways, and the class CP. In olden days we had a CP. It is similar to sitting, I think, second sitting, and class SL means sleeper class. So SR here, Southern Railways sleeper class. So it is not in olden days. It was used. Repulsion motor was used in this kind of trains or tractions, and currently it is not being used. Repulsion motor are classified under single phase motor. In repulsion motor, the stator winding are connected directly to the AC power supply, and the rotor is connected a commutator and brush assembly similar to that of direct current DC motor. And these motors are equivalent to an AC series motor. Excluding brushes in the motor are not allied with the power supply, although they are short circuited. As I mentioned, the brushes plays a major role in repulsion motor. As a result, the flow of current can be induced within the armature conductors through the transformer section. The field structure of the motor has cylindrical construction. The motor has a stator and the rotor, but there is no electrical connection between the two, and the rotor current is generated by the induction. The rotor winding is connected to a commutator which is in contact with a pair of short circuit brushes, which can be moved to change their angular position related to an imaginary line drawn through the axis of the stator. The motor can be started, stopped, and reversed, and the speed can be varied simply by changing the angle position of the brushes. So here, as I said earlier, the brushes plays a major role, and it is shorted also. Please make a point, it is shorted. Based on the angular positions, we can make the motor to start, stop, and reverse, and the speed can also be varied. Most commutator motors are limited to about 1500 volt because higher voltage give risk of arcing across the commutators. But repulsion motor can be used at higher voltages because the rotor circuit is not electrically connected to the supply. This is the important application. The working principle of repulsion motor is repulsion between two magnetic fields. For instance, consider a motor which has two poles along with the magnetic axis. The armature winding of this motor is connected to a commutator as well as the brushes. The brushes are short-circuited with the help of jumper with low resistance. This is called as jumper of low resistance. Once an alternating current is applied to the stator winding, an EMF will be induced within the armature. The direction of AC will create two poles like south and north, where a north pole can be formed at the top of the magnetic axis and south pole can be formed at the bottom of the magnetic axis. This is north and this is south. The induced electromagnetic force direction can be given by Lenz's law. As the induced electromagnetic force induces the flow of current within the armature conductor, the induced current direction will depend upon the brush positions. What is Lenz's law? EMF is equal to minus phi by t, we can keep it ns number of turns, and del phi by del t means del is small change in flux with respect to small time. The Lenz law states that induced current direction is induced within the conductor through changing a magnetic field, so that the magnetic field which is formed through the induced current will oppose the primary varying magnetic field. That's why we have mentioned as negative sign. So as per Lenz law, the EMF produced is opposing the magnetic field. Types of repulsion motor, we have three types: compensated repulsion motor, repulsion start induction motor, and repulsion induction motor. Advantages: starting torque is high, good speed regulation for sudden heavy loads, the torque can be developed, starting current will be reduced. Disadvantages: sparks will occur at the brushes, the power factor is very less at less speed, the speed at no load condition is extremely high and unsafe. Brushes and commutator exist quickly due to heat generation and arcing at the assembly of the brushes. So the speed at the no load condition is extremely high and unsafe. That is the important point to be noted in with respect to series motor. We have seen speed control of DC series motor in laboratory experiments. Normally a series motor will be started in off-load conditions. So the load, if we are not loading and initially it started at infinite speed, so that the brake drum can even move away and it can damage to the person or the equipment itself. So series motor should always started with half-load conditions. Okay, and applications used in high-speed lifts: farm motors, mixing machine tools, air pump, mining tools, petrol pumps, electrical locomotives, fans and pumps, printing presses, textile machines, and film winding machines. Smooth manual speed and direction adjustment could be achieved without complicated circuitry. Film winding machines, film roll, the motion pictures. So these are the applications of repulsion motor, and due to its disadvantages, the speed at no load condition is extremely high and unsafe. The application of the repulsion motor is limited when compared to linear induction motor or hysteresis motor. Okay, thank you.